Today's lesson is actually we want to talk about the absolute extreme points and optimizations. Again, this is something that you already studied in Math 3C, so let us just do this final part so that this part is finished and we can go to new lessons. Okay. Um, so of course here we want to talk about extreme, absolute extreme points. So for example, when I talk about absolute maximum points, I don't mean just a point which is locally maximum, which is actually higher than the points in vicinity. I mean that it is globally maximum, so it is higher than any other point in the function. Yes, of course, might be you have this situation. Let me fix the colors here. So S1, let me choose that one as well. Okay. So here, for example, if I ask you, all of you know about the graph of y equals to x squared, of course. Yes, so if I draw the graph of this, it would be something similar to this. Yes, if I ask you what is the absolute minimum of this function, it is 0. Yes, it happens here, and the y value for it is 0. So the absolute minimum of this function is equal to 0. But of course, in this case, this is also a local minimum point. Yes, but if I ask you what is the absolute maximum of this function, then what will happen? Then the answer is that there is no maximum for this function. There is no absolute maximum for this function because this function actually grows higher and higher. So there is no point that I can show that yes, this point is the highest point of the graph. Whatever you choose on the graph, there is also another point higher than that. So there is no absolute maximum for this function. Yes. And then for this is y equals to x squared. If I want to draw another picture, you can also imagine y equals to x cubed. Yes, so let me draw it here. If I want to sketch that, then the graph of y cubed is similar to this. Yes, it goes like that. So if I ask you what is the maximum of this function continues forever. There is no absolute maximum for this function, and there is no absolute minimum for this function. This function is not bounded at all. But even for this situation, if I limit myself to a given interval, okay, then, and that interval is a closed interval. So let me talk a little bit about a closed interval. So when I talk about an interval, I mean something like this. I say that x is between a and b. This is an interval. I can say that x is greater than or equal to b, less than or equal, greater than or equal to a, less than or equal to b. This is also an interval. This is usually called an open interval. An open interval. And this is called a closed interval. Of course, you can imagine that you can have an interval which is half open, half closed. For example, you can have this situation, or you can have this situation. These are half open and half closed. Yes, but this is what, when I talk about an interval, I mean something like this. But now let us focus on closed intervals and only continuous functions. Yes, so I am focusing on continuous functions on a closed interval. What do I mean? For example, let us choose between -1 and 1. So let me just limit myself on the interval, on the closed interval between -1 and 1. Then what happens? For this function here, if I give -1 to my function, the y value becomes 1. So apparently, for example, this point, and then this is one of the points, and then I put a field point there. Why? Because -1 is acceptable for me. So this point is actually a field point. So it means that I need to draw a circle, but not a, because we will have two kinds of circles. One hollow circle is small, and then one field one. The field one means that I am including that point, and the hollow one means that I am excluding that one single point. Okay. Now I am talking about inclusive points, yes, because I am considering closed intervals. So this point, and then and then if I put 1 here, I will get also 1. So this means that I am limiting myself now to this portion of the whole graph. Now let me ask you the question again. Do you think that there is a minimum? You would say yes, this is not affected by doing this. But do you think now there is also a maximum for this function? The answer is yes, because these 2 points are the highest point on this graph if I limit myself to this interval. Is that clear? So this function didn't have an absolute maximum before, but as soon as I limit myself to a portion of this graph, meaning that I limit myself to a closed interval, then suddenly I can answer this question: what is the absolute maximum of this function? You would say it's equal to 1. Yes? And here, let us go to this function here. So if I give x equals, so this is, I forgot to write, this is y equals to x cubed. So if I put 1 here in x cubed, the answer is 1. So again, this is the point on my graph. And if I put -1, I will get -1. So this is another point. So this means that if I want, of course, my picture is not very good, but you understand what I mean. So then this would be -1, for example, and this would be 1. And these are field points because now I am including them. Then what happens? Then this would be the portion of the graph that I am interested now. If I limit myself. Now if I ask you, is there any absolute maximum for this function? You would say yes, this is the highest point on the graph. And if I ask you, is there any absolute minimum for the function? You would say yes, this is the lowest point on the graph. So the absolute maximum is 1, and it happens when x is 1, and absolute minimum is -1, and it happens accidentally when x is equal to -1. Yes? So this is crucial. But then another point that I emphasize on closed intervals: do you think that an interval being closed play any role in this argument or not? What do you think will change? For example, let us consider the same scenario, but let me limit myself to half open interval. Let us see what happens. So let me limit myself to this situation. Just exclude the final end points and try to do the same thing again. So what will happen, do you think? Exactly, there would be no absolute maximum. Why? Because if I want to draw the picture again, so let me just draw this something like this here for you. Of course, if I put x equal to I'm just considering again this function. If I put -1 into my function, it becomes -1. So this is 1 point. This is field point because it is inclusive. But if I put 1 here in my function, it becomes 1, but this time this is exclusive. And then of course this portion of the graph would be something like this again. Okay? Now this is exactly that portion of the graph that you see it here, but this time I have excluded one of the endpoints. Just I chose to take it off from the right side. Okay, now if I ask you, is there any minimum for this function? Is there any absolute minimum for this function? You again will say yes, because this point is the lowest point. But can you show me what is the highest point on the graph? I hope that you are convinced that there is no highest point. Let me, for example, zoom in here. Is there any highest point on the graph? For example, is this point a highest point? No, of course not, because I have another point on the graph which is higher. So that is not a highest point. Okay. Is this a highest point? No, because the height is here, but I can go a little bit higher. This height is greater than the previous one. So this shows that this point was not the highest point. So I hope that you agree with me. You cannot show any point on the graph and say that, okay, this is the highest point. Even if you go very close to this point, of course this is continuous. I cannot show it on the picture. It might be zoom in and zoom in. There is a limitation. So if I stand here, there is still a higher point. If I stand here, there is still a higher point. Yes, and because this point is excluded, I cannot show that, okay, this point is the highest point on the graph. Okay, and then now assume that I exclude both of them. So for example, let us consider this scenario. Then what will happen? Then what will happen? Then it means that this point should also be excluded. Yes? Let me make it so here. This point should be also excluded. So something like this. Let me just be very quick. This would be like that. Now if I zoom in, then what is the maximum of this function on this interval? There are no maximum value, there is no minimum value. So it is very important to realize that having a closed interval is very crucial, actually. Okay, but now I want to ask your opinion about that. So assume that you have a continuous function and you are given a closed interval. So let me just tell you, for example, to be concrete, let me f be a function, continuous, and let me a closed interval is given to you. Okay, I want you to intuitively convince yourself that if this is the case, definitely I will have a maximum point and a minimum point. This situation that cannot occur, or this situation cannot occur. Yes, I hope that you agree with me. For example, let us test some ideas. So for example, here I have a graph. So let us, this point be A, let this point be B. Okay, so to make it sure, so let me draw these vertical lines. I want to limit myself between these two vertical lines. Okay, because this function is continuous, it means that if I want to draw the graph of this function, I can do it with just one single pen stroke. Yes, yes, something like this. But then, because these are considered to be closed intervals, it means that the endpoints should be inclusive. Yes? Okay, now try to convince yourself. I start somewhere here with the filled point, and because my function is continuous, I can go up and down in any way that I like, then I can end at this point. Again, this should be filled. This is one of the scenarios. Now, by looking at the graph of this function, do you agree that this function is definitely, there is a maximum for this function and there is a minimum for this function? Agree? There is a highest point and there is a lowest point for this function. Highest point occurs here and the lowest point occurs here. Both of them are in the interior of the interval. Yes, one of them happens at this point, one of them is happening at this point. Okay, but let me change the idea. Let me start from here, filled point. I go up and down and then I go here. So what's happening? Do you think that the function still has a maximum and a minimum? The answer is yes, but where are they happening? They are happening at where? Can you tell me? Yeah, they are happening at the end points, A and B. Yes? So the minimum occurs here, the maximum occurs here. I want you to convince yourself that it no matter, if I want to respect the rules of the game, meaning that I have to have a continuous function and I have a closed interval, then it doesn't matter how I draw the graph of the function. Every time that I draw a continuous function on a closed interval, there would be one point which is highest than every one. Of course, it might be that there are some different points. So for example, I can have this situation. So then all of these points are the highest point. But at least I will have one highest point and at least I will have one lowest point. Okay, this is what I want you to convince yourself. By drawing some diagrams intuitively, you are definitely convinced about that. If the interval is closed. But of course, if the interval is not closed, there is no guarantee. For example, assume that I start like that and I go like this. And for example, then here I have a maximum, but I do not have any minimum because that is hollow. So having a closed interval is crucial. Okay, so hopefully you are convinced that if I have a continuous function on a closed interval, then there is at least one point on the graph which has the highest height, and there is at least one point on the graph which has the lowest height. Now, another question for you. If I ask you categorize the points at which the maximum and minimum of a continuous function on a closed interval can occur, what type of points you will have? So where should I look for? Where should I look for the points at which the function has its maximum and the function has its minimum? Where should I look for them? Because of course, if you, again, don't forget the logic, if you have the graph of the function, this is an elementary problem. But you don't have the graph of the function, you just have this interval and you have the formula for the function. You want to use your mathematical knowledge to be able to find the highest value for that function and the lowest value of that function on this interval. So where do you think that these maximum and minimums can occur? I hope that you are convinced where they can occur.
They can occur at local maximums and local minimums, or at the endpoints of the.
Exactly. Thank you very much. This is the only thing that they can happen. Yes, because it might happen that I have this scenario, for example, it goes up and then, for example, down. You see, here the minimum occurs at this endpoint, but the maximum occurs here, which is in the middle. But if we restrict ourselves to also, but this is a local maximum as well. So this is a local maximum because it is higher than the points in the vicinity, and of course it is also an absolute maximum because that is the highest point. So it doesn't matter how I draw the graph. Yes, so this is not a good picture, so let me just do it like this, and then I go up to here. So here the minimum occurs in a local minimum, but the maximum occurs at one of the endpoints. So hopefully you can convince yourself that this is actually the case, that for a continuous function on a closed interval, the absolute maximum and the absolute minimum can occur in two different type of points, either at a local maximum point or minimum point within the interval, inside the body of the interval, or they can occur at the final points, endpoints. But then this will give us an algorithm so that we can immediately find the absolute maximum or absolute minimum of a function. How should I do that? I need to find all local extreme points which are inside the interval and calculate the value of the function for those values. I also need to calculate the value of the function at the final points, and then I will get a set of numbers, then I compare these numbers. The maximum value among these numbers is the absolute maximum, and the minimum value among these numbers is the minimum value. Okay, so let me write this algorithm for you. Okay, so determining absolute extreme points of a continuous, let me change this, it is important, continuous function on a, let me change again, closed interval. Okay, so how should I do that? The first step is this. Number one, determine f prime of x. Number two, solve f prime of x equal to 0 and determine the solutions that lie on the interval so let me write this interval here for you. On the interval a less than or equal to x less than or equal to b. Okay. Number 3, calculate f at the numbers at the points at the x values. Let me write it at the solutions to you got in the previous step, in step 2. Okay, number 4, calculate f at the left point and f at the right point. Number 5 is your interpretation. The maximum value that you get in steps 3 and 4 is the maximum of f on the interval, and the minimum is the minimum of f. Of course, this is not 100% correct way of writing, but you understand what I mean. So if a continuous function is given to you and a closed interval is also given to you, and you're supposed to find the absolute maximum and minimum of that function on that closed interval, you determine the points at which the derivative is equal to 0. Only you accept the ones that lie interval, yes, that lie in the interval is actually the correct word. So in this interval, and then you calculate the value of f at those solutions. You also calculate the value of f at the endpoints, and then you compare them. The maximum number that you get in these two steps is the highest value, and the lowest value that you get is the absolute minimum. Okay? Any questions? Okay, now let us do some exercises. So determine the absolute. So when you don't write this adjective here, it also means absolute. Okay, determine the maximum and minimum, if any, of each function in the given interval. Yes. So I want to find the absolute maximum and minimum of these functions. Okay. So is this function a continuous function? The answer is yes. That's a polynomial. Polynomial functions are always continuous. I have intentionally given you two intervals here. One of them is half open and half closed, but this one is closed. So for this one, there is a guarantee that we have both maximum and minimum. But for this one, there is no guarantee. Let us talk about this. Okay, let me do this step by step. So what we do is this. Number 1, the first step that I have to do is to differentiate my function. So f prime of x. It's very simple. So I take the derivative, it becomes 3x squared plus 10x plus 3, yes? And what I do, I put it equal to 0. Then what happens? This means that 3x squared plus 10x plus 3 is equal to 0. And then what I have to do is to use, for example, ABC formula. It's minus 10 plus or minus the square root of 100 minus how much? 36, and then divided by 2 times a, which is 6. And then this number is just 8, so I get two answers, minus 10 plus or minus 8 divided by 6. So then I will get two numbers, yes? So one possibility is that I add these two numbers, minus 10 and positive 8, it becomes how much? Minus 2 over 6 is minus a third. Yeah, please correct me if you see that I am making mistakes. Oh, sorry, before putting it in box, you need to check something. And the other number is minus 10 minus 8 divided by 6 is minus 3. Okay, but be careful. Before putting them in a box to accept them, you need to check which one is in the interval. This is very important. Here in my case, both of them actually lies within this interval, yes? Minus 3 is somewhere between minus 4 and 2. Minus a third is also somewhere between these two numbers. So here I realize that both of them are acceptable for me. Be careful about this point. Sometimes one of them is acceptable. Sometimes none of them is acceptable. So here in this case, both of them are acceptable. And the next step is to do what? The next step is to calculate the derivative, not the derivative, the function at these points. Also at the end points. And then you get four numbers. Comparing these four numbers are very simple. The highest one is the absolute maximum and the lowest one is the minimum, absolute minimum. So let us calculate this. So what happens here, I will have minus a third to power 3 plus 5 minus a third to power 2, and then try 3 times minus a third minus 2. I don't know, this is a bad number, so it's minus 1 over 27, positive 5 over 9, and then I have minus 1 and minus 2 is minus 3. So let me take the common denominator to be 27. So that is minus 81 here, and then I have 15 here, and then I have minus 1 here, yes? So how much is that? Is minus 67 over 27. So this is one of the numbers. Let me double check. Yeah, it seems correct. And then I go to minus 3, so it's minus 3 to power 3. It doesn't matter, you can just punch it in your calculator, that's not the important thing. So it becomes minus 27 plus 45 minus 9 minus 2. So how much is that? Is 7, yes? And you also calculate this, it becomes minus 4 to power 3 plus 5 times minus 4 to power 2 plus 3 times minus 4 minus 2 minus 64, that is 80, and that's minus 12 minus 2. So how much is that? Minus 76, it's positive 2, yes? Minus 76, yes. And then finally f of 2, it's 2 to power 3 plus 5 times 2 to power 2 plus 3 times 2 minus 2. This is 8 plus 20 plus 6 minus 2. What is this? 32. Okay, now what you need to do is to compare these numbers you have in your list. The highest value is your maximum and the lowest value is your minimum. Okay, so the maximum value of f is equal to, I hope that you agree with me, that is 32, and the minimum of f is what? The lowest value, definitely the negative one is the lowest value in this case, 27. But something which is not wanted in the problem, let me also write it with a different color here. So maximum is 32, but when does this occur? This occur here when x is equal to 2. If this occurs, max of f occurs if x is equal to 2. And then min of f occurs if x is equal to what value? This value occurs when x is equal to minus a third. When x is equal to minus a third. Okay, this part that I wrote in blue for this question is not necessary. What we wanted to know is about the max and min values. Okay, so that's exactly a Math 3C problem. Okay. But now let us see what happens if I want to consider the same function but exactly here. Can you see what is the interpretation then?
There is no maximum value.
There is no maximum value, yes, because the maximum value is of course 32 and it occurs when x is equal to 2. So what is happening? I am excluding that point, so it means that that point is now a hollow circle. And for the reason that you see, that point doesn't actually have any maximum point there, yes? So there is no maximum point. If this occurs, there is no maximum point there. So for the second part, so let me write this. If we consider the interval minus 4 up to 2, minimum is still minus 67 over 27, but there will be no maximum. Okay, so this is also something that I want you to know about this. Now let us solve some problems which are Math 4 problems, yes? So you were not able to solve these two problems in Math 3C because this needs the quotient rule and this needs the derivative of trigonometric functions. Okay, is there any questions so far here? Let us see how much space do I have. So it's better to go to the next page, yes? So this function, remember that, and the interval is this. So let me go there. Number 2, so the function is g of x equals to x to the 3 divided by x plus 2, and the interval is this one. Okay, let me double check that it's okay. Yes. Okay, what should I do here again? I need to take the derivative of my function, but I have to use the quotient rule here. So it becomes the derivative of the numerator, which is 3x squared, and I multiply it by the denominator itself, and minus the numerator multiplied by the denominator of the derivative of the denominator, which is 1. I don't need to write it then, and then divided by the denominator squared. So then what happens? This becomes 3x to the 3 plus 6x squared minus x to the 3 and divided by x plus 2 to the 2. So then if I simplify this, it becomes how much? 2x to the 2 to the 3 plus 6x squared divided by x plus 2 to the power of 2. By the way, do you think that there is a guarantee that I will have a maximum and a minimum for this function on this interval?
Yes,
Why?
because it's a closed interval.
Because it is?
A closed interval.
This is one reason. You need to give me two reasons. One for the interval and one for the function. So what condition should the function hold to get? Yes?
That it's continuous.
It's continuous. Of course, this function is not globally continuous. You see immediately that I will have some problems if x becomes equal to -2. But fortunately, -2 is not in my interval. So when I limit myself to this interval, this function is completely continuous. And then it is guaranteed that if I have a continuous function on a closed interval, there is definitely an absolute maximum and definitely an absolute minimum for my function. Yes. So that is also something it's good to know about that. Okay, so this is my derivative, and if you don't mind, let me simplify the derivative a little bit. So g prime of x is equal, I can factor a 2x squared out in the numerator, so I will be left with x plus 3, yes, divided by x plus 2 squared. Okay, and then what happens? I put the derivative equal to 0. You know that if the fraction is supposed to be equal to 0, it means that its numerator should be equal to 0. Then I get two answers by the zero product rule. Either x is equal to 0 or x is equal to -3. But only x equal to 0 is acceptable, yes, because -3 is not in my interval of interest. So this means that this is not acceptable, but 0 is the only value. So this is crucial to remember this. So not in the interval. Okay. Now I need to start calculating. I have to calculate the value of g at this point that I got here, and of course at the final points. So g of 0, I calculate g of 0, I calculate g of -1, and I also calculate g of 1. So g of 0 is simply 0. If I just put 0 here, the numerator becomes 0, the denominator 2. And what is g of -1? The numerator becomes -1, the denominator becomes +1, so it becomes -1. And if I put 1, it becomes 1 divided by 3. So these are the numbers. So then it is very easy to say that what is the maximum? Maximum of g is the highest value that you see in the list, which is a third, and the minimum of g is the lowest value that you see is -1. And of course, if someone asks you where the maximum occurs, you would say that the maximum occurs actually at point 1, which is one end point, and minimum occurs for this problem when x is equal to -1. It also is at -1. Let me see if I can just try to draw the graph of this one, but I will have a little bit of problem. So here you might see just one portion of this GeoGebra. So let me write this. I think you will see what is more or less needed. So let me bring this down, and then let us just do that. So y, of course, you would expect that the graph is not a continuous function globally because there is divided by x plus 2. Okay, so let us see how this will go. Of course, by the way, that's also a power of mathematics that you see here. So for example, this is misleading, yes, because you know that this function cannot behave like that because this seems a continuous curve, but you from mathematics, you know that there is something wrong going on, might be. So let me bring the axis in, and then let me just zoom in to see what is the real behavior of this function. If we can, this is very strange that this function is continuous. Now, this is not continuous, or is it? So no, I don't. Yeah, you see, I was actually start doubting my knowledge. So the function is not continuous. It includes two parts, yes? And that is exactly what's happening exactly at this point, which is equal to x equal to -2. So that was a very extreme case. So it was very nice, yes? Because we thought that might be this graph is not. So let me just go back again because I want to limit I. So you see, It was very nice. You see, you think that this graph is continuous by just doing some zooming in, but you know from mathematics it cannot be the case. Okay, so now let us go back here. So if you see I have limited myself, do you remember the interval was from -1 up to 1? And I hope that this picture guarantees for you that the minimum value is -1, which occurs at one point, end point. Maximum also occurs at this end point. And that is exactly to our prediction without seeing the graph of the function. Okay, yeah, so the point is that probably this will not be recorded in this trick. Yeah, everything has a problem on it. Okay, let us see how this will go. Any questions here? Okay, now let me solve a little bit more complicated one related to these, trigonometric functions. What was the trigonometric function here? So here we have this function. We want to find the same thing. Of course, sine and cosine functions are also continuous functions. You had the graph of them before, and the difference of two continuous functions is always a continuous function, and this interval is closed, so it is guaranteed that I will have at least one point which is the highest point and one point which is the lowest point. Let us detect them. So this is also a Math 4 problem. Okay, so sine minus cosine, remember that. Hopefully I can fit everything here. So number 3, I will have this function f of x is equal to sine x minus cosine x, and the interval is between 0 and pi. Yes? So what I have to do, I differentiate my function. So let me write it a little bit smaller. So this becomes cosine x. The derivative of sine is cosine, the derivative of cosine is negative sine, so it becomes positive sine x. Then I have to put it equal to 0. I don't know how many of you remember how to solve this trigonometric equation from chapter 2. Do you remember how to solve this trigonometric equation? Okay, so let me remind you, this is one of those problems that if you go back, I have solved this problem for you. So the trick is to move cosine to the right hand side and then divide by cosine, yes? So how should I write this? Let me go below it. Okay, so this means that sine of x is equal to minus cosine of x. Then I divide both sides by cosine. The left hand side becomes tangent, the right hand side becomes -1. I am on the safe side. Cosine is not equal to 0, because if cosine is equal to 0, sine is either +1 or -1, but none of them becomes equal to 0. So I am on the safe side. I can safely divide by cosine. And then if I ask you what is the answer to this equation, hopefully you remember. So x is equal to tangent inverse of -1, but plus n pi, not 2n pi. And tangent inverse of -1 is just simply minus pi over 4 plus n pi. So, and then of course n is an integer. So I have infinitely many answers. Sorry, you shouldn't accept all of them. I have infinitely many answers, but I am only interested on this interval between 0 and pi. Yes? So I need to choose those values for n so that this will give me a number on this interval. For example, if I choose n equal to 0, this is gone, and I get minus pi over 4, which is not in my interval. And if I choose negative values, definitely it will not work either, yes, because if I put negative values, I will get again negative and negative values. So the first number apparently that I can put in is just n equal to 1 for this case now. So I put n equal to 1, then what I get for x is equal to minus pi over 4 plus pi. And then if I add them, it becomes 3 pi over 4. Is this 3 pi over 4 acceptable? Yes, that is definitely on this interval. But if I go higher and put n equal to 2, it becomes 2 pi minus pi over 4, which is beyond this interval. So from all these infinitely many points, only one single point is in my interval. So let me just write it down. So the only acceptable solution is 3 pi over 4. Now I need to calculate the value of the function at this point. I have to calculate, so my estimation was very bad. Actually, the space was completely enough. I don't know why I had this impression. Okay, so I need to calculate these three numbers. So this becomes sine of 3 pi over 4 minus cosine of 3 pi over 4. So if you remember your trigonometric lessons, you can use this is the complement of pi over 4. So using these ideas, you can immediately see that this is 1 over square root of 2, and then the other one is minus 1 over square root of 2. So what is that? It becomes 2 square root of 2, but this is a square root of 2. And when I put f of 0, it becomes sine of 0 minus cosine of 0, but sine of 0 is 0, cosine of 0 is 1, it becomes minus 1. And this becomes sine of pi minus cosine of pi. Sine of pi is 0, cosine of pi is negative 1, so the answer is 1. And then hopefully you agree with me that the maximum is actually maximum. This was h function, yes, sorry. So the name of the function was h, but I used f, no matter. Okay. So the maximum value of this function f is equal to square root of 2, and the minimum value of f is negative 1. So at the level of Math 4, if you get an example, if you get a question for this part, this is the usually the examples that you get. But one point, let me go back here. How do you understand that you need to solve this problem in this way? First of all, you might see this adjective in the question at absolute maximum and minimum. Another thing is that the interval is given to you. Okay? And the other question, do you remember, that was local extreme points. So they mention a local extreme point, find the local extreme points without giving you any interval, yes? So you need to understand that you are not confused about this, okay? Any questions? Okay. Now that you know this, because this is crucial to understanding optimization, you want to optimize what you want actually. Sometimes, of course, you want optimization is a good word because sometimes you want to maximize something. If that is going to be your profit, you want to maximize it. But if that's going to be your loss, you want to minimize it. In both scenarios, I can talk about optimization. I want to increase my benefits, that's optimization. I want to lower my losses, that is also optimization. So optimization sometimes means finding the maximizing something, sometimes means minimizing something. So and what I want to tell you, for example, here I want to solve a very simple problem for optimization. I want you to understand what are the basic things that you need to know about this. What I want to tell you is that, first of all, when you talk about optimization problems, you are always looking for absolute maximum and minimum, not locally maximum and minimum. You want to really find the highest possible point and the lowest possible point. So this is always at finding absolute extreme points when you are dealing with optimization problems. And then you need to read the question, use all your math knowledge to find a function that you want to maximize or minimize it, and you need to also find an interval on which you want to maximize or minimize your function. Okay, so let us start with this very simple example. A wire 16 meters long has to be formed into a rectangle. So I have a 16-meter long cable or wire. I want to bend it in the form of a rectangle. So I have exactly this 16 meters, not more, not less. But I want to bend it in a way that it how do you say it? I forgot the word. So it's bounds, this is not the correct word exactly, but it bounds the highest possible area. Okay, so that is the goal, because you know that I can do it like this. Assume that this circumference is 16 meters. I can make it narrow but long, or I can make it a little bit wider and shorter. So I get one area here, I get another area here. The material that I have used in both of them is still 16 meters of cable. But of course, one of them has a higher area, greater area. So I want to see how can I optimize if my target is to maximize the area. Okay, so that's the question. If I ask you how many rectangles I can form, the answer is infinitely many. But among all those infinitely many rectangles, I want to pick the one which has the largest area. Okay? So what should I do? For example, you can draw a rough picture for yourself, assuming that, okay, this is the rectangle that you have made. And then, so you don't know the dimensions, so that is x and that is y. So you see that the question is that what dimensions should the rectangle have? So the questions are x and y, for example, if I choose them, these numbers. And then let us say the area is a. So I would say that my target function that I want to maximize is the area. But then I have a formula for my area. Everyone knows that x times y is the area of this rectangle. I want to maximize this. There is one obstacle in front of me right now, and that is I have a function, which I call it a, as in two variables, x and y. So far, what we have learned is just a function with one single variable. So first of all, you need to realize you need to eliminate one of these variables. Okay, and that is very easy, because if you just look into the problem, there is an extra information given to you. So you know that 2x plus 2y, the circumference of this rectangle, is supposed to be 16 meters. No matter how I make my triangle, this is my constraint. Yes? So then if I divide both sides by 2, this means that x plus y is equal to 8. And then usually let us eliminate y, so this becomes 8 minus x. So I can write the function a that I am looking to maximize it is x times 8 minus x. And now I can safely write a as a function of x. So that is a function of interest. I want to maximize this function. But is there any limitation? Is there any limitation? Limitation here means interval. Is there any interval that my variable can run through it? Of course, this is clear that x, for example, cannot be negative. The value of the x cannot be negative because it represents the length of this rectangle. But there is also an upper bound to it. Can you tell me what is the upper bound?
16.
No, x. It's not 16 because y should also be positive. Do you agree with me?
Yes. So
It should be 8. Yes? Because if x is bigger than 8, then suddenly y becomes negative. So the interval is actually between 0 and 8. Of course, if you don't like, you can just eliminate these equalities, because if x is equal to 0, then this is a degenerate actually rectangle, yes, because x is equal to 0, it seems that I am hanging the wire, yes, in this direction. Something, yes, if x equal to 0, y is equal to 8, but intuitively it should be 16. I don't know why this is the Am I doing something wrong here? No, it seems everything seems correct. Yeah, if x is equal to 0, then I will have two wires next to each other. But this is not a rectangle. There is nothing in between, yes? 8 centimeters, 8 centimeters, yes. So what we have written is here completely correct. So if you don't like it, you can just eliminate these two. So let us write it in this way. So let me write. The extreme cases are actually not of interest here. They do not happen. It is very a priori clear that these cannot be the maximum and minimum values. For example, if I put 0 here, a of x is 0. If I put 8 here, a of 8 is also 0. So definitely that is not the maximum value. But then you see that immediately this problem from now on returns to the previous problem. I have a continuous function and I have an interval. I want to find the maximum and minimum values of that function. So what I do, I differentiate this function. But if you don't mind, let me multiply it, not to escape the product rule. It's easier to do it in this way. I differentiate the function. It becomes 8 minus 2x, and I equate it to 0. Then this gives me 8 minus 2x is equal to 0. So this means that x is equal to 4. Okay, is this 4 acceptable? Yes, because it lies in my interval. And that is the only point of interest, yes? So you calculate a of 4. It's equal to 4 times 4, which is 16 meters squared. And of course, you don't need to calculate a of 0. Both of them are actually equal to 0. So the maximum value is exactly this value. Okay? But they haven't asked for the maximum area. They have asked about the dimensions. Okay? So this means that I can find x is equal to 4. And what is y? So this means that this occurs when x is equal to 4 and y is equal to 4. And it is interesting. So what is the take on from here? Is that if you want to make a rectangle with the maximum area, and if the circumference of your rectangle is fixed, make it into a square, because x is 4, y is also 4. So if I want to have the highest value of the area, I need to bend this wire in a way that it makes a square of dimension 4. So that's also very interesting. So I would say that among all rectangles with the fixed perimeter, the square has the highest area. Any questions here? So what is important is here, you see that the only thing that I struggled a little bit is up to this point to write the function and the interval. And the rest of it is exactly the problem that we studied actually a bit before this. Okay? Any questions? I think there is a time that I can solve one more problem here. So among all pairs of non-negative numbers that add up to 5, find the pair that gives the largest value for the product of the square of the first number and the cube of the second one. Okay? So, what does it mean? We have a pair of non-negative numbers, but the sum is given to be 5. So, okay, so I would say that let x and y be those numbers, yes? We want to find this pair of numbers. They are given to be positive, non-negative in the question, and we know that they add up to 5. What is your target function? So let me call it P, the product. The target function is the product of the square of the first one, which one you call the first one, which one you call the second one, it doesn't matter, by the cube of the second one. So this is your function. You want to maximize this function here. But again, the problem is the same. You have two variables, but it is very simple. It doesn't need your geometrical knowledge. So this becomes this, and then you put it here. It becomes x squared. Instead of y, you put 5 minus x to the power of 3, and then now you can safely write this as a function of x. So you got your target function. You also need to find your interval for x. Of course, it is mentioned in the problem that x cannot be negative, so the minimum value of x is 0, but there is also something for the maximum value. Yes, what is the maximum value? It's 5, because if I go beyond 5, then because of this constraint, y becomes negative, which is not acceptable. And then you can totally forget about everything, just concentrate on maximizing this continuous function on the closed interval between 0 and 5. I don't know how do you want to do it, but let us use product rule this time. Of course, you can, if you don't want to use product rule, you have to raise it to power 3 and then multiply it and then differentiate it. But I think it's better to use the product rule in this case. The derivative of the first one is this, multiplied by this one, plus the first one multiplied by the derivative of the second one. But the derivative of the second one is 3, it's a chain rule, to the power of 2 multiplied by the derivative of the base. The derivative of 5 minus x is just simply minus 1. Let me simplify this a little bit. So it becomes 2x, and then I have 5 minus x to the 3, and then I have x squared. Oh, sorry, this is a product. So I put this minus 1 here, it becomes negative, and I have 3 here, so it becomes negative 3, and then I have x squared, and then I have 5 minus x squared. So even though this is finished, so if you don't mind, let me just factorize it. I can pull an x, sorry, this 2 shouldn't be here. This 2 is outside the brackets. I take 5 minus x to power 2 here out, so from the first term, only 5 minus x and a 2 are left. And for the next one, a 3, a 1x are left. Yeah, please check my calculations. Then I will get x, 5 minus x to power 2. I multiply that in, and then what I do finally is my derivative. Do you agree? Let me just double check everything. So I did this one. Yes. Yes. Yeah, that's correct. And now I put the derivative equal to 0. Yes. And that is simple. That's a product rule. So x times 5 minus x to the 2 times 10 minus 5x is supposed to be equal to 0. So what are the answers? One of them is 0. Is it acceptable? Yes, it is in my interval. So let me, but of course that's just a coincidence. They are the same here. The other one is x equal to 5. That is also in the interval. So they are repeating themselves. So you don't need to care about them 2 times, yes? And the other one is x equal to 2, yes? Which is also in my interval. Okay, so don't think that you have to calculate a lot. You have to calculate 0 and 5. This is 0 and 5, so there are 3 numbers we have to calculate. So f of 0, f of 2, and f of 5. And sorry, this is not f, this is p. P of 0, P of 2, P of 5. Of course, P of 0, this is your target function. P of 0 is 0, P of 5 is also 0. So you need to calculate P of 2. P of 2 is 4 times 5 minus 2 to the 3, which is 108. Yes, 5 minus 3, it is, yeah, that's correct. So yeah, the maximum value for the target function is actually 108, but this is not wanted in the problem. My problem is to find the pair that gives this. So it means that the question is not finding the maximum value, is finding how we can reach, how can this maximum be achieved. So x should be equal to 2. So the answer would be x equals to 2 and y equals to, because we also have a constraint here, y is 5 minus x, so it becomes 3. So this is the answer that we want to do actually. Okay, I will upload this. This is also an important example. I want you to do this. Might be next time I can start from this example. I don't know, but we are a little bit behind the lesson, so I need to accelerate a little bit. So I will upload the video on the YouTube channel, and I will also put the link for this PDF file so that you can just download this and start solving the problem. And if you have any questions, please let me know. Okay, any questions so far? So finally, we finalized these 3 pages. The reason that it took so long time because I didn't count on your math knowledge from Math 3C, because more or less all of them was a Math 3C problem. Yes, yes. So now I would say that everything until the end of page 117 is finalized. And then you can work on problems on pages 116 and 117. Of course, I will also immediately update the school soft regarding that. Next time we will start the new lesson. So let me just stop this video.